So I only have one example that I'd like to do, and it involves this figure. Couple of lines, L and M. L is parallel to M, and they're intersected by a transversal T. So I want to come up with something that sort of feels like AIA, but in hyperbolic geometry. And so we're going to set up a biconditional, and here's the biconditional. The alternate interior angles with transversal T are congruent if and only if L and M admit a common perpendicular and T passes through the midpoint of the common perpendicular segment. Now that's a mouthful. So in neutral geometry, we know that if the alternate interior angles are congruent, then the lines are parallel. But here, parallels come in many varieties. So I want to specify what we're dealing with here. If the alternate interior angles are congruent, then L and M admit a common perpendicular and the transversal passes through the midpoint of the common perpendicular segment. So let's go this way first. Let's assume that L and M admit a common perpendicular. And let's assume that T passes through the midpoint of that common perpendicular segment. Well, I think you could probably finish off this proof, couldn't you? How would we prove that the alternate interior angles are congruent? How would we prove that this angle is congruent to that one? By golly, do you see why those two triangles have to be congruent? Do you see the missing angle pair there? Angle, side angle, correspondence? This way's easy. This way's easy. Well, the other way is a little bit more difficult. So the other way, we assume that the alternate interior angles are congruent, and we set up the rest. So here's how we set up the rest. The segment between these two intersection points has a midpoint, so we pick that. And we drop the perpendicular here. We can do that. And we just let that perpendicular intersect the other side. We're not exactly sure where or how, but we know that we can drop the perpendicular to L. That's a thing we can do from a point to a line. We can drop that. And then we just sort of let it hit the other line. We're not sure how or where. But we will be sure how or where, because looky there. Vertical angles are congruent, and so these triangles are congruent by angle, side angle, and so this angle has to be congruent to that one. There's your common perpendicular, and those segments are congruent by correspondence. So if the alternate interior angles are congruent, then not only are L and M parallel, they certainly are, but they're parallel in a very interesting way. They're parallel in the way that that allows a common perpendicular, and the transversal passes through the midpoint of that perpendicular segment. So that gives us more information than just the lines are parallel. It tells us about the kind of parallel that we've got. Okay, the rest is up to you in the discussion.